So today we will start the rest of colloidal solution or colloids. So now go to associate colloids. Associate colloids means when some substances dissolved in a medium of low concentration behave as normal or strong electrolyte, but at a higher concentration exhibit colloidal state due to formation of micelles or associate colloids. The temperature at this is known as Kraft temperature, and the concentration at this stage is known as critical micelle concentration. For example, suppose you will take soap solution. Soap solution, it is sodium derivative of higher fatty acid. So when dissolved in water, in presence of water, it dissociates into RCOO minus plus sodium plus, and this R part is hydrophobic and this ionic part is hydrophilic. So whenever a dot or a grease is present in cloth, what happens? The R part, this higher fatty acid part, though it is hydrophobic, it is attached to the dot, the grease, and the carboxylic part, due to its hydrophilic in nature, it is staying away and remain at the surface to aggregate and forms the micelles and clean the dot. So due to this polar nature, it partially, polar nature means the carboxylate ion, COO minus ion, it is polar, so it interacts with water and present around the grease or oil droplet. As a result, oil droplet is pulled away from the surface of the cloth into the water to form ionic micelles, in which it is washed away the dot. And we will come across the preparations of colloidal solutions. Preparation of colloids. First thing, the breaking of coarse higher molecules, coarse molecules into smaller colloidal limit. Second thing, this is by grouping the smaller colloidal size to higher colloids of colloidal limit. So this is two processes, one is breaking, another is aggregating. So two things are applied in this case, one is a dispersion method, another is condensation method. So is dispersion method, condensation method. So first we come across the dispersion method. In that cases, first is by mechanical grinding. Mechanical grinding means as because higher means a larger group of polymers, when it is breaking down to a colloidal limit, it is fed into a mechanical grinder which is having two discs moving opposite directions, so that the materials fed between the two discs in the form of slurry and they get into smaller size. This is of mechanical grinding. Second thing is peptidization. In this spaces, certain precipitates such as silver chloride, ferric hydroxide, aluminum hydroxide can be converted into colloidal state by addition of small amount of electrolyte. For example, freshly prepared ferric hydroxide can be peptized by dilute ferric chloride. Ferric chloride solution which is added to it, forming a brown precipitate, and excess of ferric chloride can be removed by dialysis. So FeOH3 plus ferric 3 plus ion forming FeOH3 and Fe3 plus. This is a sol. As such, the precipitate of many sulfides can be dispersed by passing hydrogen sulfide gas through water in which they are separated. Third thing, Bradick's arc method. In that case, what happens? The solutions are taken by two metallic arcs and the arc, when it is supplied with the current or electric field, it gives a spark between them, and the particles around this, they get excited and form the vapors of molecular level. For example, the copper, silver, gold, platinum, and they, whenever they are sparked between these, so they form the vapors, metal vapors, and the vapors when condensed with the water, they form the colloidal particles, and aggregating to this form the hydroxides in presence of alkali. So this is the process in which Bradick's arc method is applied. Now second thing is condensation method. In the condensation method, we will also proceed first the double decomposition. Double decomposition method. In this case, what happens? If a sol of arsenic sulfide is obtained by passing hydrogen sulfide through cold solutions of arsenic oxide in water, so forming the colloids. So arsenic sulfide, that is forming from the arsenic oxide in presence of H2S, forming water. So 3H2S. So this is arsenious sol. Sol means that is the colloid. So extra H2S can be given out by boiling the solution. Second phase, by reduction method. Reduction method, in this case, this method is used for the preparation of metal salts. That is, if you will take silver, gold and platinum, that is obtained in colloidal state by reducing aqueous solutions of their salts by reagents such as formaldehyde, phenyl carbon monoxide, phosphorus and tannic acid, etc. So thus a solution of gold chloride when treated with formaldehyde gives a colloidal solution of gold. So platinum, mercury, gold, bismuth, all these metals salts have been produced by such method. The presence of a small amount of lyophilic salt, suppose for example gelatin, is helpful in increasing the stability of this system. Next is oxidation. Oxidation method. In that cases, the colloidal solution of sulfur can be obtained by bubbling oxygen through a solution of hydrogen sulfide. So let us take H2S with oxygen. The sulfur is getting out. As sol. So oxidation of hydrogen sulfide forming this sulfur sol or sulfur colloid. Then next is exchange method. In that cases, if a solution of sulfur or phosphorus in alcohol is poured into water, a colloidal solution of sulfur or phosphorus is obtained. Due to lower solubility in water, if a solution of silver iodide in aqueous solution of potassium iodide is poured into excess of water, the complex Ag2 I- breaks down into silver iodide and iodide ion. The silver iodide is obtained in the form of a colloidal solution. Now we have obtained this in dispersion method and condensation. So how to purify the colloid solutions? So purification of colloidal solutions. Purification of colloids. In that cases, one is dialysis method, and other is ultrafiltration method. Are used. In case of dialysis, as you have already know that animal membrane, if you are taking to this and adding the colloidal solution to this with the pure or crystalloid solutions, in that whenever this membrane is dipped into a solvent, the crystalloid particles which are inside this colloidal inside the membrane with the colloidal particles, they get out from this membrane and present in the solvent, and for frequently discarding the solvent molecules, we will get this dialysis method. In this process, the purification of blood is done, and for this process you can adapt the artificial dialysis models. Then ultrafiltration. In that cases, as we know, the pure particles, they are of 1 nanometer size, so they can be easily filtered out with the solvents. Whenever the colloidal particles are larger than that of colloidal size, then this process is not possible with the filtration of filter paper. So that is why the pores of filter paper may be or is to be made very smaller size than that of the colloid particles, so that the filter paper is dipped into a gelatin, then further it is taken with the formaldehyde, so that the pores of the filter paper make smaller and smaller. In that cases, the colloid particles is separated from the solutes, and this is known as ultrafiltration. Now, some of the properties we have to mention. So, in that cases, properties we will come across, as we know, it is heterogeneous character, diffusibility, and filtrable, visible, and colligatable. So, only thing that the optical property, in that cases we have to know the Tyndall effect. So, the colloidal particles are not clearly visible to naked eye. So, it can be observed perpendicularly with the microscope to that of incident light. So, this forming the streaks of light whenever light is formed to the colloidal particles. By observing this, it forms a cone like structure, and this cone is known as Tyndall cone, and this process is known as Tyndall effect. And these are of the colloid particles. So, what happens that whenever light is subjected to put inside the colloidal solutions and observing through the microscope perpendicular to that of the incident light, this light gives a scattering of the light falling on the particles. So, this scattering of light giving a streaks, that means a dazzling type of light which is observed through the microscope and in the form of, that is, a cone. So, this is the effect known as the Tyndall effect, and formation of cone is Tyndall cone. Next is Brownian motion. As we have observed, the gas molecules, they are moving hither and thither in a zigzag path. Zigzag path means that is a straight line path. At a similar way, the colloidal particles also move in a zigzag way in a straight line path or straight line directions. Suppose this is like this. So particles will move inside the solution in a zigzag path, that is known as Brownian motion, and the movement is also a straight line direction. Unless until it collides with another molecule, the path is straight line. Then we have to know electrophoresis. What is electrophoresis? As we have observed that all the colored particles carries the charge. So when colloidal solutions are placed in electric field having the positive and negative electrodes, then the colored particles will move towards the respective electrodes. That is, the migration of colloidal particles under the influence of electric field is known as electrophoresis. To understand this, we have to take a electrophoretic it is going to a reservoir. So what happens to that? There is a boundary between the normal solutions with the solvent. What happens when electric field is introduced to this? So there is the migration of charges from negative ions to the positive pole and positive ions to the negative pole. That means the positive ions go to the cathode and negative ions go to the anode. This is anode. And this process is known as electrophoretic process. So in that case, what happens? As long as there is the electric charges around this, they can move within the electric field. But as such, the colloidal particles are neutral. Neutral means the every ionic charge is covered by the oppositely charged up ions. That is why it forms a colloidal system. And at that moment, what happens? If you take the negative ions of that covers with a cluster of positive charge around, so that there is the movement of ions, or there is breaking of this cluster while electric charge is introduced. Now next we have to proceed for coagulation. What is coagulation? Coagulation means it is precipitation of colloids. That is, or it is known as precipitation. What is that? It is a process of aggregating together aggregation of molecules colloidal particles, so as to change them into large particles. Therefore, they form the precipitation which is known as coagulation. This can be done in following processes. First, electrolysis. In that cases, the particles of dispersed phase move towards the oppositely charged electrode, and if it continues for some time, the particles moving towards the electrode lost their charges and get precipitated. This is under electrolysis process. Second is mutual precipitation. Mutual precipitation, when oppositely charged salt such as ferric hydroxide that is positive and arsenic sulfide which is negative mixed together in equal proportions, they get neutralized and disperse in the medium then settle down as precipitate. This is mutual precipitation process. Another thing is addition of electrolyte. Third process, addition of electrolyte. That means whenever a electrolyte is added to the salt, that gets immediately precipitate the colloidal solution. Adding electrolyte. So when small quantity of electrolyte is added, to the colloidal solution, to the solution of low concentration, it causes precipitation. Smaller the coagulation value of an electrolyte, greater is the precipitating power. So the quantity of electrolyte required to coagulate or precipitate a fixed amount of a colloid depends on the valency of the ion bearing a charge opposite to that of the colloid of the or colloid particles known as Hardy-Schulze law. What is that? The quantity of electrolyte required to coagulate a fixed amount of a colloid depends on the valence of the ion bearing charge opposite to that of the colloid particles is known as Hardy-Schulze law. That means the coagulation depends upon the valency of the electrolytes added to it. So in that cases, it is seen that the trivalent ions is greater than the divalent ions, which is greater than the monovalent ions. Similarly, the trivalent positive ions, that cations, trivalent cations, is also greater than divalent cations, which is further greater than the monovalent cations. So, using the divalent cations, it will give more than 70 to 80% increase in the precipitation, and similarly using the trivalent cations, it is also giving more than 500 to 1000 folds of the reaction or the medium, reaction of the colloids. So, to get this, we have to use the Hardy-Schultz rule. So, now coming to protective action of colloids. What is protective action of colloids? In the colloid medium, we will have both positive and negative. Positive negative means hydrophobic and hydrophilic ions or molecules. In that cases, the hydrophobic molecules is covered to the hydrophilic molecules. In that way, there is the charge, formation of the charge taking place. As such, the every particle, suppose a positive particle is there, it is covered with the negative particles. So, that protect the reaction or the movement of the positive ion to interact with the other molecules. So, these are the this is the region in which that the hydrated molecules of the colloidal particles are covered by a sheath of the opposite charges bearing the charge of opposite and dispersed in the medium, so that they prevent to coming for the formation of colloids with the another molecules to aggregate each other. So, the lyophilic colloids are possess the property of protecting lyophobic colloids from precipitation by the action of electrolytes. The lyophilic particles form an envelope around the lyophobic particles and thus protect the lyophobic particles from the action of electrolytes. Such action is called protective action. So, as lyophobic means, that is heading to the solvent molecules, and lyophilic is that loving towards the solvent. So, the lyophobic particle protecting the lyophilic particles to interact with the other molecules or to aggregate this other molecules, that is known as the protective action of colloids. Another term is known as gold number. What is gold number? It is a method to give a colloidal solution or to produce a colloidal solution by adding the electrolyte of a given amount. In that cases, what happens? The minimum amount of amount in milligrams of the protective colloid which prevent the coagulation of 10 ml of a given gold salt on adding 1 ml of 10% solution of sodium chloride, so smaller is the gold number, smaller is the gold number of a lyophilic colloid, greater is the protective power. So the gold number gives an important information of protecting power. Lastly, we have to come across the emulsions. Emulsions are the colloidal system in which the dispersed phase as well as the dispersed medium are normally liquids. Suppose you are having the paint and other things in which it consists of liquid such as fat dispersed in water and water dispersed in fat medium. So both are in the case of the interrelated. In that cases the particles dispersed phase giving the emulsions, and these are of bigger size than that of the salt. So we have two patterns: oil in water emulsion, oil in water emulsion. In case water forms the continuous phase, in which oil is in dispersed phase. And water is in dispersed medium. For example, milk means a fat present as globules dispersed in water. Second is water in oil immersion. Here water is in dispersed phase, and oil is in dispersed medium. For example, butter and cold cream. So both the patterns, one is oil in water emulsion, another is water in oil emulsion, both present either in the continuous phase or in the discontinuous medium. Discontinuous medium means it is a dispersed phase. So both will form the emulsions. So this completes the surface chemistry. In that cases we have studied the adsorption and the colloids. Thank you.